Hello, guys. Good afternoon. Welcome to the class. Today, we're gonna start the stage number two, which is special products, also known as notable products, and factoring. Okay, this is the stage two. So the first lesson is 2.1, special products, which is what I told you to research on your own in the last class, right? And I told you that the most important special products for us will be these three. These two, okay, which basically, if you notice, they only differ in the sign. In the middle, we have plus and minus. But in both cases, what we have is a binomial raised to the square, another binomial raised to the square. So this is known as the square of a binomial. And we're going to see both cases, when we have a plus in the middle and when we have a minus. Now, the second case, or the second special product, is this special product, which is x minus y, this binomial, times x plus y. And this is known as the product of conjugated binomials. This and this binomial are known as conjugated binomials. I'm going to explain in a moment what that means. And finally, the third special product is the cube of a binomial. Cube of a binomial, in both instances in which we have a plus or a minus. So this is the cube of a binomial. So what is this lesson about, the special products? It's about you memorizing the final product of this. Okay, for example, when you multiply these two, you're gonna get a result. We're gonna do that in a moment. Okay, when you multiply this, like you should know by now, remember the FOIL technique or any other technique that you want to use, you're gonna get a result, this thing. Okay, I'm speaking abstractly right now, and the whole goal of this lesson is for you to memorize how this will look. Why? Because these three products, the square of a binomial, the product of conjugated binomials, and the cube of a binomial, are so frequent in algebra, and we're going to use them so much that we teachers don't want you to spend time in developing the whole thing, because you can do it by the FOIL process and you're going to get the right answer, but it's going to take you more time, and it's just not a good idea. Okay, these are so common that it's a great idea to memorize the final product so that you can very quickly perform this without thinking too much. That is the whole goal. Okay, so let's see. Let's go to the first example, the square of a binomial. Let's see how this works. First of all, why am I calling this a product, right? Why am I calling this a product and also this? Well, because x plus y to the square is simply x plus y times x plus y, right? So you actually have a product of binomials. Can you see? This is one binomial. This is another binomial, which is the same, and you're taking the product. Okay. So basically, let's see what the result is. Let's multiply x times x, we get x squared. X times y, we get xy. Y times x, we get xy. And plus y times plus y, so we get y squared. And then we collect like terms, this one and this one, and we're gonna get x squared plus 2xy plus y squared, and this is the final answer. So basically we have x squared plus 2xy plus y squared. So this is the formula that you have to memorize. The square of a binomial, well, I'm gonna actually go back to the exponent form like so. Well, x plus y to the square, or the square of a binomial, is equal to this. Now let me tell you how you can read this formula so that you can learn it and memorize it completely. So we have this. Let's call this the first number and this the second number. And remember, we have a plus in the middle. So what is the formula of the product of the square of a binomial? Is the square of the first number, as you can see, plus 2 times the product of the first times the second number that appear in your binomial, plus the square of the second number. You see, that's how you have to memorize it. Well, that's one of the ways you can memorize it. If you remember in junior high, I don't know if they told you how to read this formula. Usually it was spoken in this way. El cuadrado de un binomio es igual al cuadrado del primero más el doble del producto del primero por el segundo más el segundo al cuadrado. Ups. Ok, ¿y a qué me refiero cada vez que digo el primero y el segundo? A estos números que aparecen en tu binomio. El primer número del binomio y el segundo número del binomio, separados por el signo de más. Okay, so you have to memorize this rule. Now, if you perform the same thing, if you actually went down and performed this product and you get the result in the same way that I did this one, what you're gonna find is that the end result will be x squared minus the double product of x times y plus y squared. So that is the only difference, guys. The only difference between the binomial, just give me a moment. The only difference between the first case and this second case is the plus and the minus, you see? And look at the differences in the formulas. I'm gonna erase this. We don't need it anymore. Okay, look, in this, basically it's everything is the same, basically. They're not the same, but it's basically the same. If you notice, you have x squared, and then the double product of xy, the double product of xy, and then y squared, y squared. The only difference is this sign. Can you see this plus in here and this minus in here? So you need to memorize these two formulas. Okay, so that's how you square a binomial. Now, how do you apply this? Let's look at some examples. For example, suppose I give you this binomial, 2x minus 1 to the square. Okay, how do you perform this quickly without developing the whole product? Well, you just resort to your formula. Okay, the square of the first plus twice, or the double product of the first times the second, plus the second to the square. That's all you have to do. So what is my first number here? It's all of this. This is my first number. What is my second? Well, let's make it a plus. What is my second number? This one, 1. Okay, I mean that's my second number. I'm sorry. So let's do it. What is the first term in here? It's gonna be this one to the square, like so. You see, you're gonna write it like that, and then we have a plus in the formula, and then we have a 2, and then we have our first number, which is again 2x, and then our second number, which in this case is 1, and then we have a plus, and our second number to the square. What is our second number? 1. So it's 1 to the square. So you do this first, and after you write it in this way, you can develop the parentheses. Okay, 2x to the square, that's gonna be 4x squared, and then all of this, 2 times 2x times 1, that's gonna be 4x, and then 1 to the square is 1. So this is the answer. This is what you should be getting very quickly. With some practice, you can get this done very quickly, even without doing this. You can just look at your binomial to the square, and you can go directly to this answer. But that takes practice, guys. That takes quite a lot of practice. Let's see another example. What if I give you this? 3x squared minus 2y to the cube. Okay, so look at that. You may be thinking that you cannot apply the same formula like this one. Well, in this case it's a minus, so it's gonna be this one. Okay, you may be thinking that, sorry, to the square. You may be thinking that I cannot apply this rule in here. Why? Because in the binomial in here, x and y have no exponents, and in this binomial they do. Okay, don't get confused by that, guys. What in the way in which you should read this formula, I'm gonna tell you one more time, is the following: first number and second number, whatever they are, we don't care. They can be very complex, they can be anything. Okay, so one number minus a second number to the square, that's going to be equal to the first number to the square minus twice the first number times the second number plus the second number to the square. You see, so I follow the same idea here. I have a binomial, because this is clearly a binomial. We have a minus in here, just like this, so I'm going to apply this rule. What is my first number here? It's all of this, 3x squared. That is my first number. What is my second number here? It's all of this, 2y to the cube. That is my second number. And I'm just going to follow the rule as I can see it here. So this is going to be equal to the first number to the square Can you see? All of this is my first number. Minus twice or double the product of the first number times the second number. So the product of this number times this number. And I'm just gonna put it like so. Okay, I ran out of space, so I'm gonna continue here. Plus y, I'm sorry, the second number to the square. What is my second number? It's all of this, 2y to the cube. So I write it down. This is my second number, and I square it. Now that I've done this, I can develop or expand the exponents. So 3x squared to the square is going to be equal to 9x to the 4. And then all of this multiplication, after you perform it, should give you 12x squared y to the cube plus all of this number to the square, which is going to give you 4y to the 6. And this is your whole answer. So this is what you get out of this binomial to the square. And so that's how it works, guys. It doesn't matter what you have. I'm going to erase again the whole screen. It doesn't matter what you have. For example, I can give you a very complex binomial. For example, let's say, I don't know, 6ab plus 3c to the square d. This is a binomial, right? Because it has two terms. This is the first term, second term, or first number and second number. And let's raise all of this to the square. It's a binomial to the square. And I can apply the same rule that we saw in the previous screen. So this is going to be equal to the first number to the square plus the double of the first number times the second number plus the second number, all of that to the square. Once I have it like this, I develop the exponents, or I raise each of these terms to its corresponding exponents. All of these to the square will give you 12 a squared b squared plus all of this stuff will give you let's see, 36 if I'm not mistaken. Yes, that's right, 36ab c squared d plus all of these to the square will give you 9 c to the 4 d to the square. You can pause the video and make sure that these things that I'm giving you, all of these things are in fact true or correct. So this is your full answer. So you see, it doesn't matter how complex the binomials are. As long as you have a binomial to the square, you can apply the formula for the square of a binomial. And the same for the other two cases. I'm going to do those very quickly. The other type was the product of this, okay, and I called this the product of conjugated binomials. Conjugated binomials. So first of all, let's understand what conjugated binomials are. For example, I'm going to do it in here. I'm going to give you this binomial, x minus 2. This is a binomial, fine. When you write the same binomial with the same two terms, but the only difference is the sign in the middle, like so, you see, the only difference is that we went from minus to plus, then this binomial and this binomial taken together are known as conjugated binomials. This is the conjugated binomial of this one, and this one is the conjugated binomial of this one, okay? They are known as conjugated binomials. Now an example, what if I have a squared plus b to the 4? This is a binomial. What is its conjugated binomial? It's a squared minus b to the 4. You see, I'm only changing the signs in the middle. What if I give you 3a b to the square minus c? This is a binomial. What is its conjugated binomial? It's gonna be 3a b squared plus c. Okay, so that's how it works. Those are conjugated binomials. And what do you get when you multiply them? When you multiply conjugated binomials? Let's see very quickly. So we have x plus y, and its conjugated binomial x minus y. X times x, x squared, x times minus y, minus xy, plus y times x, you have this, and plus y times minus y, it's going to be minus y squared. These two like terms add up to 0, and finally the answer is x squared minus y squared. And this is the formula that you will use in the end. The product of conjugated binomials is equal to x squared minus y squared. So basically, the product of conjugated binomials is the square of the first minus the square of the second. Let's see an example of this. For example, what if I give you this conjugated binomial? 2x minus 3y and its corresponding conjugated binomial, which is this. You see, you don't have to go all the way and do the whole product. You can go directly to the formula. Are these conjugated binomials? Yes, because they only differ in the sign. Can you see? Okay, so I can apply the law, this law. The result of this will be the square of the first number minus the square of the second number. What is my first number? All of these, 2x. What is my second number? All of these, which is 3y. And that's it. Basically, I can do this. First number to the square minus second number to the square. My second number is 3y. I perform the exponents, so we get 4x squared minus 9y to the square. And this will be your final result. You see, it's very simple. Another example, a more complicated conjugated binomials. What if I give you 3w y to the cube plus 5z to the 4? This is one binomial, and let's write its conjugated binomial. Okay, so this is a product of conjugated binomials. What are we gonna get? We're gonna get the square of the first number minus the square of the second number. What do we mean by first and second numbers? This is my first number. This is my second number. So I'm just gonna put them in here basically. 3w to the cube, all of these to the square, minus my second number, which is this, 5z to the 4, all of these to the square. And basically, I raise these two terms to the square. You're gonna get 9w to the 6 minus the square of all of these, which is 25z to the 8. And I'm done. And remember, with practice, you can get these ones done very quickly, extremely quickly. Okay, guys, so that's how it works. I think you can do the number 3 on your own. You can look it up. It's the cube of a binomial in these two ways, because I don't want to drag this class for longer. So you get the idea of how this works. The idea is for you to memorize the end products and the formulas and apply them as quick as possible so that you can get these ones done, these products, in as little time as possible. That is the idea. So that's it, guys. Now let's go to solve some exercises.